right, so we have been looking at the equation of our line. So what we did in our previous lesson is we looked at this line, which we know as the least squares regression line. Okay, so it's just the name given to that, and it's how they calculate it. And we know it had a general pattern of this a plus bx, and you've been doing the certain questions, and you've been calculating this a and this b and writing your equation. Now what we're going to do is we're going to use the equation to predict things. So what we might do, if you look at here, we're going to pop in this example, so I'll get you to pop them into your calculator in a minute. So we have the birth rate of 10 countries and also the life expectancy. And so what we're going to do is you pop them in, or we might do it later, I'll get you to do it in a minute. So we've popped them into our calculator and we've created a scatter plot, and we've got our A and B values. So we said the birth rate is the explanatory variable, so that's gone down there. Because what they're going to do is they're going to say if the country has a high birth rate, meaning lots of babies are getting born or whatever, they want to see what's happening to the life expectancy, meaning how long do you live for. So if you look at that scatter plot, what type of relationship is this scatter plot? Is it a positive or a negative? Yeah, so this one has a negative. So when you have a country with a high birth rate, what would you expect their life expectancy to be? Do they live longer or are they shorter? Shorter, that's right. So a high birth rate has lower life expectancies. So remember how we looked at, it's not the cause, it's just a correlation. So we might give out these stats, and then some other departments might go and have a look and see why is that the case. So you might, if you think of a few countries, if you've got countries with high birth rates, say like India, high birth rates, you might not see, because countries with high birth rates may not have as good as medical facilities, and that might be something else that's causing the life expectancy, so things like that. But we just look at the stats. All right, so we've got this now, we've got a formula that we can use, and that's here. So we can say life expectancy, and we can use this formula, we can use this to predict. Okay, so what we're going to do is we're going to tell you a country, we might tell you a country's birth rate is this. I want you to predict what their life expectancy is. So you can see here it says, what is the life expectancy of a country with a birth rate of 35? So into our formula, where we see birth rate, we put 35 and we calculated it to be 55 years. Okay, and then we have another one down here, another example. We said calculate when the birth rate's 70. So we've popped 70 into the formula to find out what the life expectancy. So when it was 70, they had a life expectancy of 4.6 years. So that is fairly low. So when you make these predictions, we often get asked whether is this prediction an interpolation or an extrapolation. Now they're listed up here. So I'm going to show you here this interpolation. That's when you predict within your data range. So if you have a look over here at the birth rate, the lowest birth rate you had was this one, okay? So it was about a birth rate of 26, and the highest one we had was roughly around 43. When you predict within those values, that's called interpolation. So why is that interesting? Because really, we can't really comment on what's happening outside those values because we didn't really test it. We don't know. So sometimes when we say, someone might ask us to predict, we'll predict for them, but we might say this is an interpolation or an extrapolation, because extra is outside what we were looking at in the range we're looking at. So this extra here when I say extra, that would be predicting anything less than 26 or anything more than 43. So these are the extrapolation. If you predict a number, an X number, smaller than the smallest or larger than the largest. So looking at our examples here, when we had a prediction, when we were asked to predict 35, is that an interpolation prediction or an extra in this scenario? Was 35 birth rate, is that inside our data? Yes, that's right. So this one was an interpolation. And when we checked or predicted 70, what was that one? Extra. And that probably makes sense too. See how things could change dramatically after our last one. Really, do we really think a country would have a life expectancy of 4.6 years? No, it wouldn't be surviving if that was the case. So something outside those values, it might change completely. That's why we need to let people know whether it's extra or interpolation. All right, so you got this in your notes, and you will know how, so you have your notes in your test, and you will be able to go back and write that definition of inter or extra if you have to explain what it is. Okay? All right.